Okay, let's get started. My name is Justin Smith. I'm a technical evangelist at Microsoft, and for the next few minutes, we're going to be talking about the Internet Service Bus. And I'll explain what the Internet Service Bus is and how it relates to bits that you can get today. And I'm really going to drill into how you use the Internet Service Bus to do stuff that would be really hard without it. And so this is all about kind of a first view into some of the services that Microsoft is exposing for you to consume. Okay? If you've got any questions or comments about this session, I'm going to leave time at the end. If something comes to you after this session or you're a little bit more private and you want to contact me, you can certainly contact me via my blog. The address is up there on the screen, so feel free to contact me there. I always like to start with pop quizzes, and there's going to be a few throughout this session. And let's say this question is worth 100 bonus points. So keep track of the bonus points that you accrue in your head, and at the end, whoever gets the most wins nothing. But what's a service? Anyone? Go ahead. Very good. So it has to do with functionality that you're exposing. I would take it one step further. It's some functionality that's exposed via a structured messaging scheme. This is something I start all of my presentations with. I like to sort of free your mind from the bondage of XML and SOAP or HTTP and sort of free your mind into thinking of services as this really broad thing. Okay, so if you view a service as something that's really, really broad, not tied necessarily to HTTP, not tied necessarily to SOAP, when you start to build these and you start to actually fold them into your ecosystems, whether they're enterprise, web-centric, whatever, when you fold them into your ecosystems, you start to run into a few problems. And this is really based off of feedback that we've gotten from our user and customer community. So the first one is, how do I expose a service broadly? For example, if I have two services that are talking to one another, how do I let service A talk to service B if service B is not available via a public IP? In other words, if there is a firewall or a NAT in between the two services, how do I do that communication? You might think, well, you just go open up the firewall and off you go. Well, we all know that's not always practical. You don't want to go changing your firewall configuration to allow this kind of communication. So you need sort of a generic way to safely and securely traverse the firewall. And so exposing services broadly becomes a concern. Think about what has to happen in an instant messaging scenario. This is something that's very common in the world today. I've got a little app that sits on my machine, my PC, and it's usually behind a NAT. Like when I want to talk to someone and they're in their home, if they're using an instant messenger, I can find them with no problem on instant messenger. Now that endpoint is not publicly addressable because they're behind a NAT. What they do is have a service that is sitting out in the cloud or the internet. All right? And your instant messenger client will connect up to it, and then that host that's out on the internet does the real work. Okay? So this is a lot of work to pull that off, but it's a problem that you just encounter over and over again when you start to build services. The next bullet point here has to do with identity and access control. Now, when I say we want to avoid building identity and access control silos, I'm not saying we don't want to have identity and access control in our services. Quite to the contrary. We must have identity and access control in our services. But we don't want to rebuild these silos of user information. All right? So if I've got 5 services, how do I prevent all 5 of those services from having their own silos of identity and access control? Really building these big walls around services tends to hurt us in the long run. How many username and password combos do you have today? A ton, right? I actually have a password manager to help me keep track of that. Now we have some other initiatives that are hoping to address that as well. But when you look at this in a service perspective, how do I loosely stitch together lots of different services? It's a huge problem. Also, how do I interop in a heterogeneous environment? What if I have different platforms that are trying to communicate with one another? We've addressed that to a large extent with Windows Communication Foundation. I do believe it sets the gold standard for interoperability. But what about if I'm doing RESTful communication and RPC kind of communication inside the same ecosystem? How do I deal with that? It's kind of an interesting problem to tackle as well. Then also, how do I orchestrate many service calls? So a service in and of itself is going to have some functionality. That functionality is going to be a subset of a larger set of functionality. How do I stitch together a series of service calls into some rational order? How do I orchestrate that? These are just some of the problems that you start to encounter when you start to build service ecosystems. And this is really based on feedback that we've gotten from our customer community. These are problems that everybody has. Oh, and by the way, we have these problems at Microsoft too. It's no secret. So these are also problems that we encounter when we're building our service ecosystems, whether it be the actual enterprise type products that we build inside a server and tools, or whether we're talking about our online properties. It's the same concern almost across the board. And so I want to introduce you to this concept that we call the Internet Service Bus. And the Internet Service Bus is just sort of a category of a type of service. There is no brand called Internet Service Bus. This is just kind of a concept that we're putting forth. And the idea of the Internet Service Bus is it's a set of services that we at Microsoft are hosting. And they have some purposes or some features that I think are really important. One, it's a generic way to do firewall-friendly messaging. So if I want to target an endpoint that is behind a firewall or a NAT, the Internet Service Bus has a service that will allow me to do that. Right? So it allows me to safely and securely traverse firewalls. It's also got a service that allows scalable pub/sub over the internet. Kind of cool. So we can send a message into the Internet Service Bus, and the Internet Service Bus will itself fan out to say 50 deliveries or 50,000 deliveries without any extra work by the sending application or the receiving application. So the services take care of this burst scale. If you've ever tried to build a system like that will do that kind of burst scale for yourself, it's not a trivial task. Okay? So we want to make this available as a generic service. And if you couple that with firewall-friendly messaging, then you could say, I'm going to send a message into the Internet Service Bus, and it's going to deliver it to 50,000 clients that could be on PCs behind a NAT. Ooh, that's kind of cool, right? Interesting model there. We also have some standards-based security mechanisms that allow us to delegate, if you will, identity and access control to these services. That one's a little hard to get your head around, and so I've got a series of demos that I hope will really cement that in your mind, because I think it's a radical shift in what's possible with identity and access control. So I'm really excited to show you some stuff there. And we also have the ability with these services out in the cloud to do HTTP and REST transformations. So we can really bridge the SOAP RPC world with the REST world with really no change in your application programming model. And I'll show you that again. It's a little bit hard to get your head around until you see it. It's also a standard discoverability mechanism for services. Common question we get, how do I build a catalog of the services that are in my enterprise or my ecosystem? It's a better way to put it. How do I build that catalog? Well, with the Internet Service Bus, we have a standard discoverability mechanism that's built off of syndications, where you can opt in to publishing your service into this discoverability mechanism. So that we think is really important too. And last but not least, we also have workflow. And we can allow you to build workflow over services. Now this is a little different than what you might imagine Windows Workflow being. Right? So this is workflow that is running as a service out in the cloud that's specifically geared for you to orchestrate several services calls. And that's coming soon. I generally hate pre-announcing stuff, but I just want to let you know that is well on our radar screen, and it's something that we're working quite hard on. Now, these services are available for you today in CTP form. So you can go out to biztalk.net. I know a bunch of people just said, what the hell is BizTalk? You can go out to biztalk.net, and BizTalk rocks. Great. So we got some feedback there. So this is currently in CTP form, and the name of these sets of services now is BizTalk Services. Okay? So all you got to do is go out to biztalk.net, start following the instructions, you get an SDK. I'll walk you through that in a minute. But first, I want to just get one thing out of the way. What's in a name? BizTalk Services does not equal BizTalk Server, even though BizTalk Server rocks. Okay? So BizTalk Services originated as a way for us at Microsoft to surface some of our early thinking in this world of hosted services. Right? So this is an incubation place for us at Microsoft. And we think those services that I illustrated on the previous slide are really about an internet service bus. It's a set of functionality that's generic that we think has a major transformational impact on the way we architect applications. And we're not talking about a new UI system. We're not talking about a new modeling language. We're just talking about how you stitch together applications and how you spread functionality amongst those applications. Okay? So when I talk about BizTalk Services, and I talk about the Internet Service Bus, the relationship is BizTalk Services is the name that's currently given to this concept of the Internet Service Bus. I'll try to be consistent with the names throughout this presentation, and I'm going to try to err on the side of the ISB, or the Internet Service Bus. But if I accidentally switch between the two, just a heads up, they mean really the same thing. Right? One's a concept, the other one's more of a brand. Make sense? Cool. When I think of the value of the Internet Service Bus, I literally think of like this sort of speech in front of a wall. In our application development worlds, we tend to build up walls between applications. Sometimes that's very intentional, right? We want it to be difficult to penetrate our applications, right? We don't want it to be a totally open world where there's no security, no boundaries, no nothing. But imagine a scenario where, let's say I want to take pictures from my machine, and I want to expose those pictures out to my dad. Now, let's say I'm an application developer, and let's sort of forego all of the cool picture sharing apps that are out in the world today. Let's say you're a developer, and as a developer, you want to build an app that's going to share pictures from your machine and share them out to your parents. How much work do you have to do? It's actually a fair amount of work, right? Because how do I make my pictures available through all these different boundaries? How do I deal with security, identity and access control? How do I say, all right, Dad, you're the only one that can get access to these pictures. Oh, and by the way, I've got a bunch of friends that I might want to give these pictures to as well, share these pictures with as well. Oh gosh. Well, how do we do that in a way that we don't build another silo for identity and access control? It's a tough problem to solve, right? And so when I envision the value of the Internet Service Bus, I literally think of this speech where we're saying to this, metaphorical wall of application developments, tear down that wall, please, or at least the ones that you want to. I don't know. I thought that was kind of cute, but whatever. I remember when the wall did come down. That was quite a day. Here's another way to think about it. Think of the Internet Service Bus as really being a mesh that stitches together lots of different services. So imagine down here at the bottom of the slide, we've got Fabricam, Contoso, and Northwind. I work for Microsoft, so those are really the only three company names that we can use. But imagine we've got services that are spread across different ecosystems. And I've got some clients up at the top that need to consume those services. Well, how am I going to do that in a rational and reasonable way? Well, we think the Internet Service Bus, or BizTalk Services, will basically give you the ability to connect to all of those services in a seamless way. So we view this as the fabric that allows you to stitch together applications. How do we get started on this endeavor? It's very, very easy, and it's easy by design. You go out to labs.biztalk.net. You can also get there from biztalk.net. There's several places that will get you, several URLs that will get you to the same place. Go out to biztalk.net and click Create an Account, add a username and password, and then you can associate a card space information card with that account. And you might say, well, isn't this creating another silo for identity and access control? Over time, we're going to shift this setup model so it's more open. Anyway, case in point. And once you've done that, then you can download and install the SDK. Now, I don't know about you, but I'm really sensitive about what I install on my machine. The reason being, I feel like when I install something on my machine, it's going to leave little turds behind, right? And especially something that's got the letters CTP in front of it. I'm going to be very hesitant. Now, what we're doing in this CTP is we give you some .NET assemblies. Literally, we just copy them onto your machine. All right? And we do some XML configuration changes as well. But it's basically just .NET assemblies, some helper classes, and some documentation. It's very small, it's very lightweight, and we intend it to be that way. We want it to have a very light footprint. It's also compatible with .NET Framework 3.0 and 3.5. And as I'll show you in a minute, you really don't even need to use this SDK if you want to communicate with a service that's connected to the Internet Service Bus. So this is just an easier development model, and it gives you some extra features that you don't get elsewhere. All right. So if we want to get up and running with this, let's say we want to build a service that's going to connect to this ISB and maybe listen for messages. How do we do this? It follows the standard WCF programming model. So the way we surface this, at least in the listening and sending model, is it's WCF. So if you know WCF, how many people in here have used WCF? Oh, okay, great. Almost everybody. Then this model will be very familiar to you. You just create a service contract, and in this case, I'm creating a duplex contract. So I'm going to create a callback here. Right, so I'm just changing the annotations a little bit. Now, what's the trick with callbacks? There's a little trick. If you've tried to, has anybody tried to use callbacks? Yeah? The trick is both endpoints have to have public addresses. They have to be addressable. They don't have to be public, but they have to be addressable. Right? And so when you try to do this duplex kind of messaging scenario, getting it to work when endpoints are behind a firewall or a NAT's kind of tricky. So keep that in mind. This is the problem space I'm trying to address with a sample. So we've got a standard WCF contract. And I'm going to assume, rather than show you the code, that I've got a couple of types that implement those contracts. Fair enough. Now, what do we have to do to listen or use those contracts to actually listen in the Internet Service Bus? Well, we're going to new up a relay binding. That's a type that installs with the BizTalk Services SDK. It has the same lineage as the system.service-model.channels.binding type that's in WCF and .NET Framework 3.0. That's a mouthful. Then we're going to new up a card space token provider. Now, card space token provider is another type that installs with the BizTalk Services SDK. And it's all about using a card space information card to present identity claims to BizTalk Services or the Internet Service Bus. So we knew that up, and then we're going to get the username out of the identity card that we pick, and then I'm going to new up an address. The only thing I want you to notice about the address is look at the scheme on the URI. It's SB:/WAC, meaning this is a special address scheme that we've set up to indicate to the ISB, the nodes that are running in the ISB, that, hey, we want to connect out there rather than to an HTTP address or rather than a socket address or an MSMQ address. Insert here. Then we new up a service host, then we add a service endpoint, and then we add our card space token provider to that endpoint, and then we open. It couldn't be any easier. Right? So this is very straightforward, standard WCF. That's all you got to do to make this service visible from behind firewalls and NATs. That's it.
So one question that might be coming up is just for clarification. What you're basically doing is building a client for having some published message, correct?
Yeah, so this isn't really multicast. I'm going to show you some topologies a little later on that show you some of the options of how you can do messaging in this system. So multicast means something very special here. That's the fan-out capability, and I'll show you that as well. This is I don't want to call one service or the client because it has to do with intermediaries. You view the ISB as an intermediary. And so this is actually the ultimate receiver that we're building here. So this is the receiving application. Another application is going to send a message into the ISB that the ISB will then deliver down to this receiving application. So I wouldn't want to call this a client. Okay, now how do we build a client? So this is the sender in send and receive terms. Well, we new up one of our callback contracts. Then we follow our WCF programming model, create a duplex channel factory, Call create channel. Then we call the method on the proxy. And then we say, yeah, we just sent a message to the bus. That's it. That's all there is to it. Couldn't be any easier. Let me show you that. Running. All right. Here's our little app. I've got my contracts just like we saw in the slide. I've got my little service just like we saw in the slide. And I'm going to go ahead and start it. Now notice when it starts up, I'm asked for a card space information card. This is a way for me to identify an identity when I connect up to the ISB. Right, so I've got one already set up. That's my dog Allie there. So I send that on in. And we see that the service is indeed ready. Okay. Now I'm going to start up a client. The client is also going to ask for a card space information card. I'm going to send that in. And we just sent a message to the bus and we got a call back. Now, this on the face of it is not very sexy. And you might say, why in the heck are you showing me this here? It's a console. This host could have been at my home office. This host could have been in the window in the Microsoft campus in my office in Redmond. And it would have worked exactly the same. It happens to be on my machine right now, but I could have put one of these apps somewhere else, and it would have just worked. I don't know about you, but when I saw this for the first time, I was aghast. Because if you try to write this on your own, it's actually quite difficult. It's not impossible, but it takes senior developers quite a while to pull this off. And it also happens to be expensive code to maintain. Right? So it's not that it's impossible. Lots of companies have done this kind of stuff. Our vision is, though, to make this part of the application platform for development. It's just a tool at your disposal. This will not solve world hunger. It's just another tool that we think is quite powerful. Okay. Why do we do this? Why are we investing here? This is part of our evolution towards software plus services, this vision that is more of a service-enabled world. It is integral and part of our corporate vision. It comes up whenever you get one of our top executives in front of the press. They talk about this stuff. Ballmer talked about it yesterday. Ray Ozzie talked about it during the keynote as well. This is part of where we are going as a company. Composite applications that span systems that stitch together and define ecosystems is an important part of what we're doing as a company. We've also gotten a lot of feedback from customers and partners. So we rely on you to let us know what you'd like to be able to do as part of the platform. It's been very important there as well. And we also think this opens the door for lots of cool new applications. Stop and think about it for a second. Does anybody use folder share? A few people? How about Groove? Yeah? How about Xbox Live? Yeah? Okay, a few more. So these are kind of interesting applications. How about an instant messenger? Yeah, okay, right? So there we hit the big one. So when you think about those apps all have kind of the same set of problems. They got to do that firewall-friendly messaging. They've also got to do identity and access control. They've also got to do discovery. Right? There's a lot of different tasks that are kind of similar when you abstract them up a bit. And what those companies have done, they've all bitten the bullet and said, we're going to implement this in our own proprietary way. Folder share for sure. Groove for sure before it was part of Microsoft. Everyone just went out and implemented this and did it as best they could. So imagine if this is just part of the platform. That feature set's just part of the platform. How much more would you be able to do? You wouldn't be focusing on the plumbing, you'd be focusing on the actual functionality. And we think that's a big deal. There's a question? Yeah? Presence? So presence could be part of a service that you build. So whenever your presence changes, you would publish a message into the ISB, and then whoever is interested in that would be the subscriber. So that's totally there as well. Now this is not in any way, we're not trying to overlap with what's out in the live API. Right? This is This is intended actually for lots of different scenarios, but this may have the biggest impact in the enterprise. We're not sure, right? We're building this. This is incubation, and we rely on your feedback. Yes? Are the callbacks long-standing connections? I guess it depends on what you mean by a long-standing connection. So a socket in and of itself is going to be transient. But what we do underneath the covers, above the sockets layer, is we try to make we reconnect. So we have built into our stack a reconnect and a keep alive sort of algorithm that is really taken largely from what most instant message, applications actually do. Because we didn't want to be special. We wanted to follow what was already out in the marketplace. So when you look, excuse me, at the BizTalk Services gross anatomy, you can kind of break it up into 3 big chunks. The first 2 are out today. The third will be out soon. Messaging. Right, we've talked a fair amount about messaging, and I've kind of waved my hands more about identity and access control. They actually have different URIs, but they're part of the same umbrella, this BizTalk Services or Internet Service Bus umbrella. I'm going to drill in a minute into the messaging, some of the different capabilities in the messaging infrastructure, and then we'll switch to identity and access control. So from the messaging side of the house, this is kind of how it works. Now, these are great animations, and I want you to just kind of ooh and ah as you see them. So imagine in our world, we have a few different machines. All right, so on the left-hand side, we've got a laptop, we've got some PCs on the right, and a laptop on the right. Now, let's say that all of these applications that are running on these machines connect to the Internet Service Bus, and they connect using a URI. So the machine on the left is connecting to an SB:// blah, 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 /foo. Same thing with the machines on the right, the applications on the machine on the right. Now, let's say we send a message into the ISB. The ISB will then fan out and send those messages to those applications on however many machines there are. Here it's 2 because it was hard for me to put 50,000 on here. Right? But you could imagine this fan-out capability where we can deliver this to lots of different machines. This is very different from a polling mechanism. So if you look at syndication today, you're really reliant on a polling system to try to get updates. And that's certainly standards-based, all there. It's great, it's fantastic, but you still have to poll. This is a lighter way to do it, where you get the on-demand notification, where it's more real-time. Okay, that's the concept there. This is not polling based. Although, at the network layer, we're having to do some polling to keep connections alive. Now, if we don't want to do that pub-sub model, that multicast kind of a model, maybe we want to be very specific about where we're sending a message. So here's a slightly different model. I've got some apps that connect to the ISB, and notice the foobar URI as opposed to the foo URI. So when we send a message into foobar, the ISB will then route it around to the machine that's connected to foobar. Kind of cool. Pretty straightforward. All right? So that's kind of directional messaging. Now this is really cool as well. All those topologies that I showed you just a minute ago had the messages going through the ISB. What if I don't want to have the latency that's sort of inherent in the ISB? So remember, the ISB is a series of intermediaries. That's going to cause some latency in the message exchange, although we think it's really, really good and really, really scalable and highly performing. Is there a way to sort of allow or broker a connection directly between 2 machines? So we have this option called Direct Connect, where we have a server that's sitting out on the ISB. Well, now it's a node, right? It's going to be a bunch of nodes soon. And the concept is it's a probing server. So you connect into the probing server, it gets your socket address, and then it tries to broker a direct connection between 2 endpoints. So when you send messages using a direct connection, you're not having to send messages through the relay. The relay is just brokering the direct connection. I think that's pretty cool. Now, it doesn't work in all scenarios, but it will work in some. Okay. Now, discovery. Services will opt in to a discoverable mechanism, and right now it's just a simple syndication. It's an RSS feed. So when you connect into the ISB, if you want that service that you're exposing, is just available in a general feed, and I'll show you that in a minute. Okay? And it follows a hierarchy. It's just a naming hierarchy. So we use URIs as a way to structure the different services that are there. It's very natural. It follows the model of the internet. Now, I really struggled with whether I should add this slide to this conference or not. Because anytime we say something WS star in the web-centric world, it kind of goes, what? But WS addressing, if you're going to like any WS star spec, WS addressing is the one you have to like. It's just too cool not to like. I'm a real big fan of WS addressing, and BizTalk Services embraces WS addressing because WS addressing gives you really rich intermediary support. I'm not saying you can't do it with REST. You can do all that with REST. But WS addressing is specifically geared for this kind of messaging scenario. So BizTalk Services embraces this from to, relates to, fault to, reply to model that's in WS addressing. And so with BizTalk Services, what we're doing is changing or modeling the to address for a message and the via address. So when I connect up to BizTalk Services is keeping track of my actual network address. But when I send a message into BizTalk Services, I am giving it this fake address, SB:// whatever. So once the ISB gets this message, it says, all right, I have now a message that's addressed to SB:// whatever, foobar. It looks up in a distributed hash table that's inside these sets of nodes. It looks up in a distributed hash table. Where should I deliver this thing? What are the actual, first, what's the machine, what's the name of the machine inside of my mesh that has a connection to this address, sends it to that machine. That machine then sends it back down to the actual listening app. So this is all done inside of a highly scalable mesh that we've got running in our data center today. Pretty cool. Yeah, well, 2 is actually addressing the SB:// address, right? Exactly. So it's an interesting model there, and it just kind of highlights the power, in my view, of WS addressing. And I don't really want to dwell on this, but I just thought I'd throw it out there. Now, let's say you want to take the view of, I'm not so sure I want to do the SOAP RPC style messaging, I'd rather do something like REST. Or let's say I've got a heterogeneous environment where I need SOAP RPC kind of communication and REST kind of communication. We expose an endpoint in the ISB today that will transform, if you will, RPC style messaging into REST style messaging. When I talk about REST, I'm really talking about 3 key points. 1, embrace the URI. 2, deal with your HTTP methods, GET being the most special one, and HTTP headers like content type express extra information, and they can also be the data model. So we do that style of messaging inside the Internet Service Bus, and today the API for doing that REST style transformation is a little bit different than the .NET Framework 3.5 API. So I talked yesterday about some of the cool .NET 3.5 RESTful and web-centric capabilities. Today, there's a little bit of a misalignment between the BizTalk Services SDK and the Orcus capabilities, the 3.5 capabilities. We're going to merge those over time. So it's just kind of a temporary thing for now. I'll show you this in a demo, so hopefully it'll make more sense. And the demo is going to be picture sharing. That wasn't random what I brought up earlier, right? So it's simple picture sharing. It's code that I have written, okay? So I've got a picture store on the left-hand side of the machine, or left-hand side of the diagram, and I want to allow that or make that visible to clients that I choose are worthy of seeing my pictures, right? So let's see this in action. So the base code that I used to write this is available on samples.netfx3.com/picture services. So there's a .NET 3.5 sample that's specifically for taking Windows desktop search information and making it available as a syndication. So I started with that as a base. Now it's got WCF services on the front of it, but because there's not parity between the BizTalk Services API in regards to REST and the WCF API, I had to add a shim in front of Picture Services. And that shim has a very simple contract. That's the contract right there. So I've got to use a raw message type to be the return, and I'm not using any arguments in the method, although I could have added some. Now the interesting thing here is, what is the action set to on my operation contract? It's get, because I want to deal with HTTP gets. Okay? So this is, again, a little bit different. But when I go into the implementation here, I've got to actually parse the URIs that are being passed into this service. So the implementation is really about parsing the URI and then returning the right syndication. It's not that difficult. Right now, it's just a little bit more code than you'd have to write otherwise. Now, let's look at this simple syndication. So I want to zoom in on the address. Localhost 8000/pictures. So this is a syndication that's being served on my machine. Now, how do I serve this more broadly? Interesting question. Well, I use the service that I just showed you, and I get something like this. Not that one, this one. connect.biztalk.net/services/JustinJSmith/feed. And now I've got exactly the same feed out on a public endpoint that I had otherwise internal. And I really didn't have to write that much code to do it. Very straightforward, very easy to use. And once there's parity between the .NET 3.5 API and the BizTalk Services API, it'll be even easier. Now these are just pictures that I've got cached, right? So I'm not running this real time. But notice, I will in a second, by the way. Notice I can even drill into this and say, you know what, get me a particular picture. Get me a particular picture. And this is pulling that picture from Windows Desktop Search, which has a COM API. So I'm using COM interop to go out to Windows Desktop Search to get a picture from my machine. Now, if I look right here, was there any difference? So this is Windows Desktop Search connected to the web. This is effectively what we're doing. Remember, when I just click on this link to take me here, I'm doing an HTTP GET. That HTTP GET is on BizTalk Services, right? That ISB node, that ISB mesh. That ISB mesh says, okay, we've got an HTTP GET that is coming in for this resource. The mesh, this ISB mesh, then says, okay, I'm going to wrap this up into a SOAP message. I'm going to wrap this up into a SOAP message. I'm going to weave it through my intermediaries, and I'm going to find the service that is actually listening on that endpoint. Then the ISB sends the message down to that service that could be behind a firewall or a NAT. The service then gets the message, says, okay, I've got to generate a response, then sends the response back up to the mesh. The mesh then says, okay, I've got a response, routes it back to the browser. So we've got RESTful endpoints, SOAP messaging, and on the end, it's just simple REST. Make sense? I think that's really cool. I don't know about you. I think it's really cool. I don't know about you. So the browser here doesn't know anything about SOAP. There is no SOAP toolkit in the browser. All we're doing is a simple HTTP GET. We're passing in some headers. So I make an HTTP GET for a resource. That resource, if you will, is actually the representation of that resource is being served by the ISB. The ISB then takes that request, that HTTP message, wraps it up in a SOAP message, routes it through its infrastructure down to the actual application. Then it gets routed back through and then transformed back into a response. Pretty cool. Yes? Yes. Yeah, there is a cap today on message size, and we're looking at how to do streaming in the future. So right now we have a hard cap on message size. I would throw a number out there, but it might well be wrong. But we've got a cap on it today because we don't do streaming, so it's all buffered. We are looking at how to change that and how to do streaming through this system. So one of the problems I ran into when doing this, if I had a really big picture, like I had some massive pictures, and they wouldn't go through. Right? I was like, oh, okay, right. So I've got to just pick smaller pictures, right? So, but that's a problem that we're aware of. And again, this is an incubation, so this just shows kind of some of our thinking, right? Some of our thinking is it's really powerful to have a generic intermediary, right? And we'll deal with the other stuff as it comes up. Okay, one more question. Yes?
Are you considering making this available as a product so it could be an intranet service bus for an enterprise?
So the question is, are we thinking of making this a product so it would be installed on-premise? Is that generally your question? And we've heard that feedback a lot from customers and partners. Certainly it's been feedback in conferences. It's something that we're thinking about. We really want to make sure that we can get this up and running, scaled, the whole 9 yards, inside our own data center before we try to shrink wrap it and even talk about how we're going to do that and how we're going to sell it and all that. We want to make sure we get it done here first. There's another interesting approach that I want to just throw out there today. This team is radically different from other teams inside of Microsoft. There's a couple things that are really important here. One, they drop code often. So it's like every 6-8 weeks, there's a code drop. And what's so cool about this is it's not, okay, we're going to go into a cave for 2 or 3 years, community, and we're going to come out with something that's just going to wow your socks off. Instead, what we're doing is making this stuff visible. So we're making this stuff visible on the internet. So you can just go see our new code drops. So every 8 weeks or so, I'm not promising an 8-week delivery date, but that's been kind of the history. We add some more code out to this SDK. We add more features out to the service, and we say, please let us know what you think. So hopefully in the end, this will be something that will solve lots of problems for you. That's the idea. We rely on your feedback. We have aliases and people dedicated and committed, more importantly, committed to making sure that we absorb your feedback. So if you use those links for feedback, that stuff does not go ignored. We really take it very seriously. Okay. I would show you a little bit of the security bits here, but I want to go back to the presentation and then we'll drill into security there. I think that's probably the best model. So another pop quiz. What are the first 2 lines of code in all applications? And I've got these quotes around them because you can't really use these universal statements all the time. What are the first 2 lines of code that are in all useful applications? Well, I believe it's the following. Who's the user and what are they allowed to do? It's a problem in all kinds of applications. And in BizTalk services and the Internet Service Bus, we want to give you the option to delegate identity and access control to a service. Those first 2 lines of code are not trivial to write. Who is the user and what are they allowed to do is not actually 2 lines of code. It can be a lot of code to try to answer those 2 questions, right? And if we can safely and securely allow you to delegate those 2 questions out to a service, we believe it will once again allow you to focus more on what the app is doing rather than building another silo for identity and access control. And so we've got a very flexible model here. We're not saying here's another identity model. We want to work with everybody. Right? So we have card space tokens, or card space information card support, username, password support. You know, there's live ID integration going on there as well. So we want to be this kind of model to allow you to delegate identity and access control for a whole set of different scenarios. Now, this is something that you can really wrap your head around if I show you a simple video. And so I'm going to go back to PowerPoint, to my laptop here. Sorry. And we're going to talk about this scenario. So let's say we've got a factory. And in that factory, We've got robots that build stuff inside the factory, right? So they're little robots that actually build, I don't know, widgets. Fair enough. Now imagine you're an application developer and it's your job to build the application that's going to control the robot. What are going to be your primary concerns? How do I deal with the low-level message exchanges with the robot? I care about how I tell the robot how to do something and how I get feedback from the robot. Those are going to be my two primary concerns. If you're going to expose that feature set more broadly, you're probably going to use a service, or you could use a service. So if you want to allow other applications to control and move and get feedback from the robot, you're going to build a service. Well, as soon as you build a service, you've got to think about, well, who's the user of this service and what are they actually allowed to do? Because we don't want rogue parties taking control of our robots and moving them all around the factory. So you're a developer, it's your primary goal to deal with moving and controlling the robot. Why now do you want to suddenly think about how you're going to delegate or deal with identity and access control? It's a real pain in the neck. So the developers chose to delegate identity and access control out to the ISP, right? So from inside the factory, they are delegating identity and access control to the Internet Service Bus. Now, it just turns out that the robots are controlled by remote contractors. So you've got people off-site that are using little Xbox 360 gamepads to move the robots inside the factory. And so the way this works is a contractor will present an identity claim to BizTalk Services, and then it will get back a claim set. That's just a map of what that contractor is allowed to do, for example. That claim set then gets forwarded on to the host application. The host application demands the presence of those claims before you can actually move the robot. So here's kind of a taped video feed coming from this factory. All right, so this is something we taped a little bit earlier, but it's that scenario. On the left-hand side of the screen, we've got the application that's connected to our Xbox 360 gamepad. Okay? So we've got a contractor on the outside that's moving their gamepad, and where they're moving the gamepad shows up in the UI. That gamepad, or that application, is then taking the message and the claims and sending it to this app on the left-hand side. This is the host application on the left-hand side. That host is actually moving the robot. Make sense? So we're going to pick up the video there.
A video feed directly from the Contoso factory floor. In the foreground, we see a robot. We call this one Waldo. It's a really hard-working robot. Right behind, or in the background of this shot, we see a couple of what I'm guessing are factory superintendents. They appear to be just kind of standing there, and the one in the black coat seems to be gesturing. So I'm going to show you what it's like to be one of these remote contractors that's controlling Waldo. Now notice I can move, as a remote contractor, I can move this robot around in circles, I can move him forward, and I can move Waldo back. Now the reason I can perform these operations is I've logged in to BizTalk Services, and I've gotten a claim set back from BizTalk Services. I then pass that claim set to the host application, and the host application can then move the robot. So let's say as a remote contractor, I'm moving around the factory floor, and I need to pick something up on the factory floor. So I open up the jaws of the robot, and I move forward, and then I close the jaws of the robot, and oh my God,
somebody get an ambulance.
We've got a workplace accident. The superintendent was cut in half. And clearly this is not something that the remote contractor is allowed to do. So this is an operation where in this service-enabled world, we can remedy this situation very quickly.
Now, an on-the-ball factory superintendent notices what has happened and needs to revoke my ability to close the robotic's jaws, because there is a corporate policy that says only senior management is allowed to chop workers in half. So the superintendent will log on to BizTalk Services. So I'm going to go to biztalk.net and click the Sign In button. And we're going to use CardSpace to sign in. This happens to be the superintendent's CardSpace information card, and I send that to the service. I go over here to the rules, and this is really a mapping for me to say the claims that are going into BizTalk Services will generate these claims coming out of BizTalk Services. So I go to these claims transformation rules, if you will, and I scroll down here, and we see up at the very top, I've got this mapping that says if the username is Justin J. Smith, that's me, then we're going to grant the moveRobot.closeJaws claim. Notice right below it there's another claim for stopping the robot. So every kind of operation there is on the robot has a claim associated with it. So all the superintendent has to do to revoke the claim is just click delete. So they click delete and say OK. So revoking a claim is that easy with BizTalk.net.
So our other superintendent has just changed the claim set that our contractor, which happens to be me also, is issued for moving this robot. So as a remote contractor, the next time I refresh my claim set, I'm going to go ahead and do that now. And when I refresh my claim set, I send my card space information card back to BizTalk Services, and I get a new claim set. Right? So I've now got my new claim set that does not have the closed jaws movement. So I can still back the robot up. I can still move him around in circles. And I can also open the jaws of the robot. So as we approach this other superintendent with our jaws open, if we try to close the jaws of the robot, look at what happens. We're not allowed. And if you notice from the controller application, it turned red. That close button turned red. And this is because my new claim set does not contain that close jaws operation. So the contractor's not allowed to close the jaws, but they can still work with the robot in other ways.
Okay. So hopefully that drives home the power of what it means to delegate identity and access control. A couple things I want you to notice here. I didn't have to bounce the host application. So when we changed identity and access control, we left the host application running. That's because that host is simply demanding the presence of claims. If those claims are there, great, you can use the robot in this case. If a claim is not there, like stopping the robot, then you can't stop the robot. The closed jaws claim is not there, you can't close the jaws of the robot. So it's a very elegant way to delegate identity and access control. And if you can do this for something as goofy as a robot, a Lego robot that I built in my office, you can do this for lots of different scenarios, right? So this is quite a powerful model. Oh, and by the way, this model is not a new model. What we're doing is making the concept of WS Trust more approachable. Right? So we're making this really easy to use because we're hosting this stuff for you. Right? So that's the idea. Right? And Vittorio, standing in the back, can certainly tell you this is not a new model. But what we're doing is just making it more approachable. So we think this is part of the power of BizTalk Services in the Internet Service Bus. Anybody have questions about this video? No? One. Yes? Are we passing the claims each time we make a request to the service? What I needed to do was get a new claim set. And so in this case, I am passing them every time. But there's the concept of claims is a really broad and flexible model. So there's lots of different options in the sort of wild for this. But in this case, that's what we're doing. Any other questions? All right, cool. I want to show you one other thing with our identity and access control capabilities here. There's another cool feature set that we call federated HTTP authentication. And we've also got an API for managing these rules. So HTTP authentication means I can secure an endpoint that's exposed in that REST endpoint, that HTTP endpoint. Notice when I just showed you the screen, I just said I can go to connect.biztalk.net/services/JustinJSmith/feed, and I can see my pictures feed that was generated by Windows Desktop Search and some other apps. Well, I can secure that endpoint. I can say I want to control who's got access to that endpoint. And that's what we mean when we say federated HTTP authentication. And then we've also got an API for configuring those rules. Remember in that video, I went out to a website and I said, I'm now going to revoke the claim or the claim mapping for Justin J. Smith to get the closed robots claim. We've got an API to allow you to set up those rules, to modify those rules. So I can say, here's a service that I'm going to add a new rule to. And this is all in the BizTalk Services SDK. And the SDK is simply really a client-side face for the services that we've got in our data center. Make sense? So I want to show you a real quick demo of how this kind of fits together. All right. So here I've got a host application, and this host application is simply going to connect to the ISP, just like we saw in our BizTalk Services 101 demo. Very simple, very straightforward. What I want you to look at is the address that I'm trying to connect to. The end URI segment here is rule test. Okay? Now I've got a client that is also going to connect to the same address, rule test, and it's going to try to send a message there. All right, so let's see this run. So I'm going to start up the host. It's going to ask me for a card space information card. All right, so we're listening at connect.biztalk.net services Justin J. Smith rule test. And now I'm going to start the client. Now, the client was not able to send the message to that rule test endpoint. I wonder why. Well, if we go out to biztalk.net, and we sign in, we'll see the rules that are associated with that rule test endpoint. And so when we kind of look through this list, it's a little bit hard to manage just because of where we've got the UI right now. We're going to change that in the future. But there is no rule that says if Justin J. Smith asks for this service, allow him. All right, so I've got simple rules to find up there right now. So that's one way that I can deal with managing those rules. But I've also built a very simple WinForms application that helps me work with those rules in a non-web-centric fashion. So if I want to build a website that exposes the same capability, I can do that. If I want to build a WPF app or WinForms app that exposes that same capability, I can. I just chose a client-side model here. So if I look in this model, there is no rule that says I should be able to connect to rule test. All right? So I'm going to define one. And I'm going to map that resource to Justin J. Smith. And if I've been living well, which I have, everything works as planned. All right. Now, let's go back and rerun the client. I'm not changing the host. The host is still running in the background. Oops. Fantastic, eh? Let me make sure I got this. Yes, sorry. That's what I needed to do. Try it one more time. Well, it is very secure, isn't it? Okay. One more time before I quit. No. Let me try that. Man, I have gone all week without bonking a demo. So the last one, I bonk. There's something that I'm doing with constructing the rule that's not going quite well, right? So one of the takeaway points here that we've heard from the community when it comes to defining these rules is we want them to be easier to build. Right now, it's a concoction of the resource, the URI, and then the operation that you want to build on, or you want to perform on that URI, right? And so you just kind of have to work with the grammar there. But if you look at kind of the claims for, like our moving the robot, which are right here, right? The grammar is fairly straightforward, right? But there's some catch that I'm not getting there. Localhost federated robo service move robot dot close jaws. Map that to Justin J. Smith. Well, there's SB, so there's SB type operations, and then there's operations that map another way. So anyway, I'm not going to dwell on it because I'm probably doing something stupid. I'm going to post the answer on my blog, believe me. I don't like to end on that kind of a note. So I think the takeaway points for biztalk.net in general is we're taking common problems that you have when you try to build service ecosystem, and we're trying to make that functionality that allows you to stitch them together, make it available, in our data centers, in a set of hosted services. That's the concept behind biztalk.net. That's the concept behind BizTalk services. And there's one last slide I got to show, and it is one of my favorite slides of all. It's your potential and our passion. So guys, thank you very much. I hope you picked something up about this. And I'll open it up for questions, comments, or personal attacks. Yes? So we'll, today, so the question is, if we're doing federated HTTP authentication, what are the ways that we're getting this identity claim from the user? And right now, for federated HTTP auth, we do card space and we do username password. In the future, we're going to enhance that offering. Another question. So the question is, how are we doing load balancing in the data center, or?
Let's say I've got one service name, control robot, right? But I have span out over 4 different boxes, and I have all my users telling me that one control. Is there individual load balancing policies that are?
I'm not sure I understand the question. So inside our data center, we've got heavy use of load balancing. If you have multiple endpoints that do the same thing, are we load balancing that? Maybe come up afterwards and I'll be able to grok it a little bit more, but it's not. Yeah, I'm not quite grokking what that is. Okay. Other question? Yes?
Two concerns, capacity and reliability.
Yes.
What are you doing about that? What are the plans for the future?
Capacity and reliability.
Yeah, capacity in terms of the number of, I don't know, calls that you'll be able to take. It's going to be always.
So the question is, what are we doing for capacity and reliability? For the capacity side, our vision is to, at some point, make this scale to hopefully whatever anyone would want to use. Today it's CTP form. This is our incubation area, but all the code that we've written, we have been fanatically devoted to the idea of no restrictions on scaling. So all the code that's running inside the data center is specifically geared to have no bound on what you can scale it to. As far as reliability goes, I guess the reliability could mean a couple of different things. A common question that we get is, what are you doing for durability? So if I send a message in and the client is not available, is that going to persist to when they are available and you can then deliver the message there? That's something that we're looking at, for sure. Yes? Are we going to charge for this service? So yesterday, there was very senior executive comments about that, and I'm going to defer you to the Ballmer Guy Kawasaki talk yesterday for that.
What can we be doing now to prepare for that? Yeah, I think that days away will be used by us. We have some security requirements, some third-party requirements. Probably not able to do that yet.
So the question is, what can we be doing now? One, WCF gives you a very easy upgrade path to this model because the service touch point is going to be WCF. So the more familiar you can get with this model with WCF in general, the better off you are. The other thing I would encourage you to do is please use the SDK in sort of incubation style approaches. So don't throw it into production or anything. But let us know what the feedback, like what you think and features that you would want. That will help us deliver a set of services that are more useful in your scenario. So we're actually relying on you, and you could view this as we're either stealing your ideas or we're helping, helping deliver something that makes sense to the broadest community.
So I'm shocked this question hasn't been asked, but the whole idea of anybody kind of hosting and mediating all of the traffic messaging going through a bus, what is your position on that? Kind of what is the messaging? Not with the PR perspective.
I'm not a PR person.
But you've got some opinions, I'm sure.
Yeah, and opinions are just that. So we're just trying to give you more choice. That's all. So if those sets of problems, those dilemmas, are things that like ring true, it's like, yeah, we have that problem a lot. We have this problem of siloed identity and access control. We have this problem of how do I expose services more broadly. We think that this will be a very nice solution for you. And so that's really what I've got to say there. We don't ever see this being something that's like, going to replace the traffic on the internet or anything like that. This is for addressing those kinds of problems that I opened up with early. Yes, sir, and then I'll go to you. In regards to the direct connect, there's a guy that I can direct you to for the specifics of how we're doing those direct connects, and I'm gonna hold off on answering that because I'm not certain of all the specifics there. So the question is, no, we don't have any of the folder share code. So folder share was an acquisition, and the feature set that they've got, really one of the most interesting points is how they're hooking into the NT change journal for files and how they know when a file is actually changed. Not so much the endpoint bit, right, and how they get through the firewalls.
Any plans on supporting like third-party authorization like OpenID?
Any plans on OpenID? There's a lot of discussion and talk happening about that right now, and so I don't know what the latest rev is. This is something that we've got our eye on, and we want to make sure that this is a model that works with the most options. So we're in no way, shape, or form are we trying to further any sort of interest that says this is the Microsoft way of doing things. Honestly, at the very top of the ladder, the people that are running this project, they are committed to making sure there is a solid ecosystem with different approaches and different frames of mind that will work here. So I can't really address that in particular, but it's something that we're thinking about and we're committed to. Committed to the approach. Right? Other questions? Yes? I'm going to sit down.
Can you address message security? I realize the host is uses HTTPS, but can you address message security from back and forth to the service bus?
Yes.
And also, are there some pub-sub examples that we get to others?
Are there some pub-sub examples?
Yes.
So the answer to both questions is yes. There is message security and there are pub-sub examples. Both of those are in the SDK. So we have code that shows you how to do both.
And I further that same concern, and I'm sure you're aware of this too, that there are some verticals out in the marketplace that even with the potential security in the SDK, can be a little reticent to use this type of technology. However, it would be really great. The question is that are you going to open up the API so that the service bus doesn't have to use the Microsoft hosted platform, but there was effectively a third-party hosted platform that did exactly the same thing?
So the question is, how are you going to open this up to third parties for hosting the same idea? One of the here's the system that we don't want to have happen. So we've got this set of capabilities, and we don't want to say you either get the whole set or you get none. So we want to make it possible to say I want to do my identity and access control this way, but I also want to do messaging this way using the biztalk.net ISB model. So we're trying to figure out how to make that work, right? And so this is something that we've got our eye on. And you actually raised another point. I think it might be slightly on a different tangent, but how would I work in this environment with Java? So I showed you how to do simple gets for an endpoint, but what if I wanted to, instead of using WCF to publish in, what if I wanted to use Java? Or what if I wanted to use, Python? Something like that. How would that work? And that's stuff that we're looking at too. So we want this to be as open as we can make it. The distinguished engineer that is the architect of this is a guy named John Shuchuk. And he is 100% committed to making sure that this is an ecosystem. That's about the best I can offer because it's an incubation, And so I have to be a little bit restricted in what I say. Other questions? Okay. Well, if you think of any, please contact me on my blog. My email address is justinsm. You can send me a note there as well.